Hey there, Davidson here. I thought we'd take a little bit of time to break down Activity 2.3.3 Coding with G&M Code. The objective of this video is for us to go through this entire assignment in some detail, but the beginning parts of it, I'll just read through the introduction, point out what the resources are, and then what the procedures are. Once I'm done with that, I'll go through the rest of it with you and break down each of the individual parts a little further. I hope you enjoy it. Let's start with the introduction. In this activity, you're going to learn how to communicate with the CNC machine. You'll learn how to read and interpret G&M codes before creating your own handwritten G&M code and simulating the machining process of carving your initials into stock with PathPilot HUB. This activity will require you to submit one Google Doc where you provide evidence of the work you completed, but to also utilize the provided resources to complete the work. This means, and note that I've italicized and underlined this part, it is imperative that you follow all directions. Failure to do so will result in points lost from your overall grade for this assignment. The activity is broken down into major steps, with each preceding step needing to be completed before moving on to the next step. It is on you to seek out additional assistance when needed. This assignment will contain the procedure step as a kind of checklist for you to follow along with. Next section, resources. You do have quite a few resources in this assignment. G&M Code initials layout page. There's a paper copy of it here for you if you have a printer or you have one printed out and you want to use it. G&M Code initials layout. This is the same thing but as an Onshape file for those of you that would like to do this digitally. G&M Code coordinates sheet. It's a Google Doc used to help you organize your coordinate values for each labeled point. There's two parts to it. There is an absolute coordinates part and there is a relative coordinates part. NC Code Planning Document. This is another Google Doc to help you organize your G code as you write it. And then PathPilot HUB, which is access to a simulator for testing your code. You will need to create a login for this. It's free. It should work on all computers. Definitely let me know if you have some issue with this and we can work together. And then the last thing is the G&M code presentation that we went through in class. I did make a recording of it for you so that you can go back and reference it as needed. It's already up on YouTube and right here for you. I do plan to go through the resources a little more in depth with you and show you how to use each one, but I want to get through the procedures first. The first step in the procedures is to plan out your initials. You need to use the provided G&M code initial layout document. That's going to look like this by paper, or you're going to have the Onshape document, whichever one you find to be most useful. You're going to draw straight lines and arcs that create your initials as capital letters. You must design something that contains a minimum of 3 arcs. For my initials A, W, and D, the top of my A has an arc, and the top right corner and bottom right corner of my D has an arc. Mark all of the endpoints and center points on the grid intersections. If you're going to do it on paper, you're going to darken in some little circles, some little dots. If you're going to do it on the Onshape file, you're going to have to use the point tool to be able to identify these points. Label each one of those points in your design with an alphabet letter. Start at A, so that's the first point that you would want your tool to go to, and then if necessary, continue on past Z. So the second point would be B, then the third is C, fourth is D, so forth. So on. If you get past Z, go to AA, BB, CC, and if you have to go beyond even those, you're probably using too many points, but you can continue with AAA, BBB, and CCC. Easy to do by hand right on the G&M code initial layout document, but if you are using the Onshape file, you must use the Markup commenting tool that is available on that software. Let's talk about your absolute initials. You need to fill out the absolute G&M code coordinate table. You're going to enter the absolute coordinates for each point that you labeled on either your paper document or your Onshape document. Use a copy of the NC code planning table to fill out and organize what your G code looks like for the absolute coordinates. This is intended to help you with making sure you have everything you need for each one of your blocks or lines of code. Making sure that you have all of the coordinates correct and that they're labeled properly on the layout document, and then using those two together to be able to write your G code in an organized table is very useful. You would repeat this process for the incremental and relative initials document as well. You need to fill out the relative G and M code coordinate table and enter the relative coordinates just like you did for the absolute ones, but obviously the values will be different. You're still going to reference the points that are labeled on your G and M code initials layout doc or Onshape file, and then you're going to use a copy of the NC code planning table. Scroll down a little bit further and you'll find the relative code planning table. This is still intended to help you make sure that you have everything you need for every line or block of code. For the next part, you're going to create absolute and relative codes text files. That's .txt files. These are what we're going to use for the simulator to understand what your G code is like. This can be done in a variety of different ways, but you will likely need to clean up the code after you've copied and pasted it in if you do all of your code writing by computer. And what I mean is that when you're using the NC code planning table, you're probably going to type things into that table as opposed to handwriting it after printing it out. I would recommend that you do type it in. It's a little easier to change and fix, and you probably won't misread any of your handwriting. But if you then copy all of that data, all of that information, and you drop it into some type of text file or code writer, or you put it into a Google Doc and you export it as a .txt or save it as a .txt, then you might have to go in, and probably will, and delete a bunch of spaces and line things back up. It's actually less tedious than it sounds, but it is a good way to go about doing this. So you can copy and paste the information from that document straight into either a Notepad or Notepad++ if you have that software on your computer, and if you're using a Windows-based machine, you likely do. If you're using something like a Chromebook, you may not have access to that, but check and see. Good news is, if you use a Google Doc to do this, you can copy and paste it right into a Google Doc, and then when you're ready, you can go up to File and go down to Download As, and download it as a .txt. There is a third option though, and it's called Code Writer. It is an app that I have on my computer, and I find it very useful when I'm trying to do things like writing code for G code. If you have access to the Code Writer app, you're more than welcome to use that, as you can save as a .txt as well. Whatever you do, when you save this work, make sure that you save it with your name, first and last, _absolute _gcode.txt. And of course, for your relative one, it's your first and last name, -relative -gcode.txt. The reason that I change it from underscore to hyphen is so that it's very clear which one is absolute and which one is relative. This just makes it easy for me when I'm looking through them, and hopefully for you as well, so that you don't click on the wrong one when you don't mean to. Number 5 for this procedure is PathPilot HUB. You've probably never used PathPilot HUB before, and if you have, great. If not, don't worry, we will take a look at it a little more in depth in a bit. But for now, know that you're going to use it to test your code and capture, I would recommend, an ISO and top view screenshot of the PathPilot HUB screen. You can edit your code directly in PathPilot HUB to correct any mistakes and then just run it again. But keep in mind, even though this can be done in PathPilot, your .txt files, your NC code planning tables, your absolute and relative G and M code coordinate tables all need to be then updated by you before submission. You cannot go from PathPilot HUB back out to a file that your computer will understand. When we look at the documents that we put into it, you'll see what I mean. Then at the end, we're going to get into the submission here. Create a Google Doc. This is separate from anything that you've gotten out of the resources. You're going to make your own Google Doc. Put it in the same folder where you're keeping everything else that you've now taken from these resources. Create a Google Doc and name it your name _ A2.3.3 _ code writing with G&M. Write a few well-written paragraphs to start it off. Detail what your successes and failures are with this assignment. Now, likely you will be doing this towards the end. I'm picturing probably on the last day is when you will do this, because you'll need to document what your successes and failures are. But if you're really good about it, you're probably going in and keeping track of what those successes and failures are and maybe jotting them down in a Google Doc that you've already created. Include some screenshots on this Google Doc of your PathPilot HUB end results for both absolute and relative code writing. In other words, take some pictures of it. I would recommend that you use the screen capturing tool that we've shown you to use throughout the 4 years that you've been with us, and then save those as pictures that you can drop in. That's a good way to do it. You know how to insert files and documents into something like a Google Doc. Photos are no different. Include your final G code and access to your copies of all of the documents you got out of the resources that you used to complete this project. Think of it like this. If you go to your CDF and you create a folder called 2.3.3 and you just start putting everything into that folder, and I'm shared on your CDF, you are giving me access to those documents. But I would just double check to make sure that you have given me that access by going in and seeing if I am in fact shared on those files. The individual files are a great thing to make sure that I'm shared on. I don't mind getting the email saying that I've been shared with this. However, when you use the Onshape document, if you choose to do so, you will need to not only make sure that that link to that document is in this Google Doc that you've created, but that I am also shared on that document as well. If I don't have access to a document, I consider the fact that it wasn't turned in or did not work and is a broken link as far as I am concerned. Now, I do provide a separate submitting part down here at the end just to kind of wrap things up for you. Be sure that, and I'm going to reemphasize this a lot, you submit a link to your Google Doc when you submit this assignment. Make sure that Google Doc is shared with me, Adam_Davidson at dpsnc.net, along with all of the other documents that you have that are probably either hyperlinked into this and or you've made some copies of and put them in some fashion. So one Google Doc that you're turning in, it is a hyper document. It has pictures in it. It has your hyperlinks to other documents you've been working on and have completed. Anything that I need access to be able to see, you need to make sure you provide it for me. You need to do this on your own to some extent. I don't want to spend my time double checking with you to make sure that it has been shared. If you have shared it with me, you should be able to go into the share permissions and see my name or email there. Don't forget to share everything with me. And I think I've made that very clear. This assignment is worth 150 points. Here is the breakdown of it. And this is also what you can find most likely on the objectives for the day that you're working on this. The Google Doc with well-written paragraphs that detail successes and failures, evidence of all the work you have accomplished is linked and or provided as part of this document. Successfully creating 2 files that PathPilot HUB recognizes and allows you to use. Screen captures of the PathPilot HUB window, at minimum an ISO view. I would encourage multiple different views. ISO and top is a good one to have for each of them. So we're talking about both on your relative and absolute files. G&M code initials layout is completed and shared. Again, if you're going to have The paper document, you need to make sure that you have a copy of this somehow. Picture of it is a good idea because you're going to draw on this most likely with a pencil or pen. If you're going to use the Onshape document, you need to make sure that I'm shared on that. The G&M code coordinates, this is updated and finalized, and that Google Doc has been hyperlinked in the submitted Google Doc that you're turning in. The NC code planning document that you've made a copy of and that you have updated and finalized after making sure that any and all mistakes are taken care of is hyperlinked and submitted as part of the Google Doc you're turning in. Points will be deducted for mistakes, missing components, lack of detail and explanation, poorly written paragraphs, hyperlinks that are broken or files that are not shared properly, and files not being updated after the simulation is complete and you have discovered some type of error within them. This is all due by the due date that's on the calendar. Good luck, and let me know if you have questions. Now let's dive into some of those resources. Let's get into some of those resources a little deeper. When you click on the G&M code initials layout paper copy, it does take you, as a hyperlink does, to make a copy of this document. Be sure that you change the name of it from copy of to just having 233 at the beginning. Feel free to put your name at the front of it. You then need to move it from just My Drive to a folder that is within your CDF that you've shared with me. If you don't do that, I likely won't have access to it. You can double check on this by going over to Share and seeing who exactly has permissions to see this. Make sure my name does show up here and add me if you need to. Once you're on this document, you'll want to print it out if you don't have a paper copy of it, and then you can start drawing on it. So here's a paper copy of the G&M code initials layout sheet. You may notice that the graph paper is a little bit different than what you saw in the example from our presentation. Each of these grid lines represent a 1/16 of an inch. And in our mill, typically tool 1 is an 1/8 inch tool. So you'll notice, say for my A, I start at point A down in the bottom left corner of the left rectangle. And this point lies at the positive 0.3125 in the X position and the positive 0.3125 position for Y. From A, I move to B. From B, I move around point C to point D. This is the way that I like to do it. The way that you label these is up to you, but it does make sense to go as sequentially through the alphabet as possible. It does not make sense to me personally to make my center point around the arc D, but this is a common practice that people will utilize. It is up to you how you manage that, but I do go from A to B, from B around point C to D, from D to E, then I come back up out of this wax block and I move over to point F. Again, I am not moving too far to the left that I would go outside of the boundaries of where I'm allowing for these letters to be placed. I do move through the inner rectangle, and that is totally fine. Keep in mind the inner and outer rectangles that you see here, simply that space will indicate for us how wide the tool is. So when I go from F to G, you can imagine the grid squares above that horizontal line and the grid squares below that horizontal line will be eaten up by my tool. Once I get to G, I come out and I wrap it over to H. When I'm at H, I plunge back down and then do a linear interpolation to I, from I to J, J to K, and K to L, which I then come back up out of my wax. I wrap it over to M and I plunge back down into the wax, and I do a linear interpolation to N, and I do an arc around O to point P, then linear from P to Q and around R to S. and then I go linear to T, and from T back to M. So M is where I end, and I will come back out of my material and then make my way to finish my program. The important things to note here are that as I am traveling in any kind of circular interpolation, say from B to D around point C, I'm doing so in a clockwise fashion. So I will need to use the G code that represents clockwise. All right, same thing happens when I go from N to P and from Q to S. Now, if I had come out of L and rapid traversed down to T and then decided to go along the bottom from T to S and from S to Q, I would have to use a counterclockwise rotation for my circular interpolation. Either way is fine because we are using wax and we're not going to get into the logistics just yet of what it means to cut into material with making the tool dig in or pull the material out, and dependent on the way that the spindle will turn versus how you move through the material, that can happen and cause some issues if you're dealing with a much more dense material than something like machinable wax. So this is pretty much the end of my G and M code initials layout page. I have labeled each of the points. I've darkened in those areas so that I can see them. My F and G points could use a little bit of touch up on the darkening of the points, but they are at least labeled, and this is now going to be easy for me to translate what these coordinates are when I move this into my coordinate table. Now that we've had a chance to see how the G and M code initial layout paper copy works, let's take a look at the Onshape file. That's the second hyperlink that you see here. When you click on this, it'll immediately open up a new tab that brings you to Onshape. You have to be signed in with your account to Onshape. If you don't have an account, you will need to create one to be able to do this, and that is a completely separate issue that we can help you with. When you do click on this file and open it up, it opens as something that's only been shared to you with view abilities, but also with the ability, since it is a public document, and you can see that here, to make a copy of it. And this is the only way that we were able to make this available to you. So you click on this button here after being signed in, and you can rename this and copy what you see as the active workspaces to a new document. So here I'll want to refer to this in a way that makes sense, give it a name that is appropriate for this assignment. And then in this case, I'm just going to come in and say first name and last name underscore, just to keep it somewhat consistent with other file naming schemes that I might be using. And I'll say OK. So once the file does load, it looks like this. My recommendation is to get familiar with what you're seeing. You can go look at the example, and we will in a moment, but I'd like to point a few things out to you. On the left-hand side in the file tree or in the browser tree, you see that I have made some very easy to understand names for each of these. And after the ones that you should not modify. That doesn't mean you can't turn them on and off. It just means don't go in and make changes to them. I say don't modify. So the main sketch of this wax block is here. The wax body as an extrusion is here. Don't modify either one of those. The ledge that you see going around the side, its sketch is here and has been turned off. The ledge itself as an extrusion is here. Don't modify those. The grid that you see on top of all of this is a sketch, and it is currently turned on. You'll need to leave it on momentarily, or at least while you're drawing your letters. You'll see later that you can turn this off. The grid numbers as a sketch are here, and as the actual numbers themselves being extruded upward is here. Please don't modify those either. The orange boundary and the blue boundaries simply represent, just like on the paper copy, that space that you should try and stay within and that you can cross through. There's nothing really special about these rectangles other than I'm wanting to confine your letters to these particular areas and let you know by showing you the orange space that is going around the blue rectangles, that is a space. If you used an 1/8 inch tool and cut all the way around it, that's the amount of space that it would take up. So when you draw a line that runs, say, from the point here in the bottom left corner to up here, it will chew up this entire orange boundary area. You can cut through the blue area if you need to. There's no problem with that. I just want to indicate for you that this is still an open usable space, and don't go beyond this line, this line, this line, or this line down here if you want your tool to stay within the orange boundaries, and you do. And then there is one sketch that's provided that says modify, and this is the sketch I've put on here that you can use. You'd want to double click on this sketch to go into it. Now that you're in the sketch, you can do things on top of here. The nice thing about Onshape is all the sketches below are still referenceable, I suppose is the right word to use. Up here at the top, you have all the different sketch tools. The ones that you'll be using the most are point and line, but you will need to be able to make some arcs if you want this to work properly. There are a couple of different ways that you might go about doing this. You may even find that something like a spline comes in handy, but that's going to be tricky to find all of the points for. So try to limit yourselves to point, line, and arc. Let me give you some examples. If I wanted to use the A for my first initial, then I might come in here and say, all right, I need to start at this point and move up until I get to the 1.3125. Now, why I chose this spot is because I'm going to want to arc all the way over to this point here. And if I count from left right here all the way over to the right, I find that it's 1, 2, 3, 4, 5 to the center, 6, 7, 8, 9, 10 all the way over to here. So if I go back to that 5 spot in the center and I go up 1, 2, 3, 4, 5, I'm at the top here. Now I could push it one more up, but if I go up one more, I'm going to want to go up one more on this side as well. So you want to be careful where you place your points and your lines and your arcs to make sure that you're maximizing the space. When you go to draw this, you can delete things on this sketch. Just be careful that you don't delete other sketches. I'll start by drawing a line. Now at this point, I can't really grab anything right away. There's nothing popping up for me, if you will. What I like to do is utilize the point tool. If I come in here and I say, all right, I want to place a point somewhere on this grid, all I need to do is gently move my mouse so that it identifies these grid lines for me. You'll notice that there's some lines that do pop up that look like they're construction. This is part of a pattern that I've had placed down on this so that I get the 4 corner points as they're already located. I'm going to go ahead and come on up here and go to the, let's see, it looks like probably 1.375. I'll place a point there. I found the intersection, click to place it, and then I'll come over here, hold my mouse in this area for a moment. Remember, this file is kind of big. It's going to take it a second to recognize everything. Move my mouse slightly so that it picks up all the other lines underneath it. I find this intersection and I place a point. I go to this midpoint here and I place a point there as well. Slight movement, picks up the lines. Perfect. Right there. Now, I could come down here and place these points too. They are there and I can reference to them, so that's kind of useful already. Let's see if I can just pick up a line and draw from this point down here. Move my mouse slightly to be able to pick it up. Yep, it finds it, makes it coincident with it, and I'll draw a line that goes up to this one. Now, immediately you might find that it's best to go ahead and draw all of your points in, and you can do that if you think that'll work. You might also find that it's useful to draw in the lines that you know you have points for one letter at a time. So I'll drop down from this one, as that's what I like to do next, and then go down to that point. It is trying to get me to draw another point right away, but the next thing that I want to do is draw an arc. There are a couple of different arc tools that I can utilize, but in this case, I could do something like a 3-point arc or a center point arc. Let's try the center point arc. Click on center point, find this point here in the center. There it is. And then it wants to know, where do you want to start? Well, I want to start here on the left and sweep out around to the right. And then if I can, snag this point on the far right. Boom. I need to add another point, as I need to cross through my A, and I'm going to place that at the 1-inch mark. And again, this is up to you where you place these things. Your letters are obviously going to look different than mine. This is just an example of how I go through it. I click there, I click to the other side, and then, oh, did it give it to me? Yep, okay. Click to the other side, which looks like it's slightly off. I'm going to go ahead and undo that last point and try again. See if I can actually pick up the intersection. There it is. And then I'll draw a line between those two. Keep in mind, if a line is blue and not black, it is not fully constrained. And that's the whole point in laying down these points, is that I want to try and fully constrain this sketch. And all just for the purpose of it being neat and looking good and showing or proving that I have the skill to do this. All right, so that connects those 2 points together. And if this turns black, it is fully constrained. If not, there could be some other thing that I can do, placing a dimension or providing some location dimension if I need to for it. There, it's turned black. It does take it a second, so bear with it. It's slow going, but I promise drawing it with a straight edge over here and planning this all out takes just as long. So once I have all of my letters drawn in here with all of the points, what do I do with it next? Well, this is where you have to make some decisions of what looks good, what's easiest, what goes well with your style, if you will. What I like to do and what I think is the best thing for you to do, because you can provide a picture that you can then insert into your Google Doc that you submit at the end, is to come over here to comments. Okay, so let's imagine for a moment that my A, my W, and my D are all in here. I would come over to comments. There are a couple of different types of comments that I can provide. I can tag things, I can mark up things, and then I can also browse for an attachment to put them in. The best thing, in my opinion, to do is a markup. I'm going to click on markup here to show you what this looks like. All right, so if I mark up this sketch, right now it looks good. The grid lines are turned on. I'm on an arrow. If I come in and say I'm on a text, and then I change the color to, oh, let's see, something that'll show up really well. Let's go with blue, see if that shows up. And I'll go real thick as well. Then I'm going to come down here to point A. Click and drag a little box out. Give me a sense of where it is. I have found that it's difficult to move them afterward, so placing them where you want them to be the first time around is probably the best idea. Control Z to undo is pretty useful. And that's close enough, so I like that. I'm going to move up here to point B, draw in a second one. So I had to click outside of the A and then put in a B. Click outside the B, put in my C. I'll put it down here. D and E. Let's put it on this side. And then I've got to put an F over here. And oops, there I've made a mistake. That G is going to be way too small. So I'll hit escape because I didn't type anything in. And I can just redraw that square. There we go. EFG. Okay. So I would do this for all the points in the W, all the points in my D for Davidson at the end. And when I'm done, I can hit this check mark. Now what this does for me is it makes a little JPEG over here under this comment. And then I would say, these are my labels. Until you type something in that comment box, it won't work. I'll say add, and it adds it for me in here as a comment with a nice picture of what I see. I can then click on that picture and voila, I have a graphic with all my letters labeled, very clean, very neat. It looks great. Okay. I also, because I've provided all of these numbers moving up the grid and numbers moving to the right on the grid, giving you the ability to, within 1/16 of an inch, mark out what each of these letters represent in their coordinates. Hopefully this will help you as you move forward with using the next resource. If you want to see what this looks like as a final version, I'll show you. I have also turned off my grid lines to make it a little more clear. So give me 1 second and I will show you that. So you may notice that I'm now on the example tab that came along with this file, and it's down here in the bottom middle area. So wax block initials was what I was just working on a moment ago. This is the example one that I've provided for all of you so that you can see how my initials turned out. They're like this. Notice that they kind of disappear once the sketch has been closed or finished. Back over here, you'll see that I'm still in this sketch mode. Okay. Now that grid that we have kind of gets in the way. So if under example, you can see that I've gotten out of the initial sketch. These turn into the same color as my grid. So it is helpful for the grid to then be turned off so that you can see your actual letters. But the problem becomes lining them up with the correct number. So bear with it. Do the best you can here. Sometimes it helps, at least in my opinion, it does help that if you have the grid on, you can see the points much better. But also, if you're back in the actual initial sketch, they turn black and they show up really well. You can go into the comments like this, or you can go into the comments like this. That's what I did the first time through. And you'll see that over here, because this is my tech teacher account as opposed to my Adam Davidson account, the markup that I had before is here. So let me show you what this looks like if I do this with the grid lines turned off. I'm going to go ahead and place, let's see here, delete this one and place a new markup. And I could come in, oops, Control Z. I can come in and place a letter like so. And when I'm done with this, it'll give me a comment that I can click on and look at. And now you can see what it looks like with the grids turned off. Okay, so this is your call as to how you go about doing this. The comment is going to be your own comment. It just simply makes a picture that you can then do what you need to with to be able to put into your document that you're going to submit. Keep in mind, if you look at it without it being in the initials sketch, you will see this as closed profiles in some places, like the top of my A or all of my D, and the lines are grayed out. So I had to turn off the grid lines for that to be able to show up. But if I do it where I'm utilizing not turning off the grid lines and being inside of that initial sketch, they show up really well, and I can leave the grid lines on so that I can tell where all the points are. This is up to you. You need to be making these kinds of decisions on your own for what works best for you. Remember, 2 paragraphs or more that tell us about your successes and failures. If this is one of those things that helps you, Fantastic. One of the other things that I hope does help you and that you will need to be providing when you turn in your Google Doc is this hyperlink, the G&M code coordinates. Make a copy of it, rename it, and put it in your CDF. Make sure that I'm shared on it and that can be accessed through your submitted Google Doc. This is where you'll use your Onshape file or your paper copy to come in and tell what the absolute coordinates are for point A and point A's X and Y and point B, point C's X and Y, D's X and Y, all the way through until you have gotten, in my case, back up through M, right? So I had to go from T back up to M at the end. So I would need to make sure I know what M's coordinates are for sure to be able to finish it off, and T as well. So I'm going to get my way back around to T. Okay, cool, I'm good. This is simply, this sheet that you're looking at on your screen is simply a way for you to organize your coordinates and keep thought of what they are so that you can reference back to them. There's nothing super complicated about this. You just simply type your values into these cells, whatever they may be. It's easy to have a typo, so having it typed in as opposed to written in actually does work really well because erasing on top of this is going to be difficult. Plus these cells are kind of small, so we could fit a bunch in. This is the absolutes, and here is a space for the relatives. We did bring you all the way through triple Z in case you needed that many points for your letters. But if you're doing that, good luck. That's a lot of lines of code. All right, the next thing to consider is the NC code planning document. Now this is the bread and butter. This is the thing where you're going to actually write your code. This is a good document to always be coming back to and make changes to as you find with the simulator what does and does not work. I've done the best that I can to be able to provide you with as much info as possible on this page. So if you see that the first page here is an absolute NC code planning page. Safe position is 0.1 above material. Cut depth, so I'm going to cut down each time I go down. I'm going to go down by a 1/16 of an inch. Basically what this means is that if I'm cutting into my material, I want to make sure my tool is a 1/16 of an inch below the 0 mark in the Z direction. Run our spindle at 3000 RPMs, a feed rate of 20 IPM and 9 IPM for curves and plunges. We do like to use a slower speed at curves, even though the presentation that you watched probably just prior to this didn't recommend that. I am recommending it to you, especially if it is a practice type thing that you're doing. Going through those curves in metal, you're going to want to go slower, so might as well practice it in the wax. The machine can handle the wax at probably 40 IPMs. It does start to get a little rough and maybe some skipping that happens, but it's wax. We can chew through it pretty quick. Write the G&M code that would allow for an 1/8 inch end mill, so a flat square end mill, that's going to create the design using the absolute coordinates. I have given you your first block. N01, the G codes that you would want to call out is a G90, 90.1, and G20. The second block, the second line of code, is a G43 and an HO2. Now you can look up what a G43 is. A good resource that I have not provided for you just yet is to go to Tormach's website or to just simply Google search G code, and you can probably find all kinds of things about G code out here, especially if you want to get into things like G code Tormach. See what it tells you. Oh, hey, look, a G code for Tormach list. Imagine that. Supported G code reference sections on the Tormach website. Programming G code for Tormach. Machine code reference introduction for Tormach. These are some really good sites for you to go to, as they will give you some of this information that you're looking for. Like, why did he say to use a G43? What is that? Our tools in our ATCs are sitting inside of what are referred to as tool holders. The ATC slides over and the spindle uses air to open up a collet and grab the top of that tool holder and pull, and actually stays in place, and the ATC moves, keeping this tool now in the spindle. But that tool inside the tool holder that's in the spindle, that's inside the collet in the spindle, has a length, and we have measured all those lengths down to a 10,000th of an inch, and then we have input them already into the machine itself, into the computer that's at the CNC mill. And that machine needs to reference to the library that this particular tool has a distance to it. So if I say go to a 0 depth, it doesn't put the collet on that wax. It puts the tool's end on that wax, and it knows how tall that tool is inside of the tool holder that's now sitting in the spindle. This is a very important thing that I can really best do in person with you, but the idea is that the tool has an offset length, and I need to tell it to apply that offset length. The next thing that we'd probably want to think about here is, where does it go look for this offset length? And that, my good friends, is the HO2. This tells it, look in the library and look at this tool in the library. But you may notice that this tool says HO2 instead of tool 1. Well, this is the bummer part of it. You're going to have to go in and make a modification here, because HO1 is what it should be looking at, not HO2. You could also change it to tool 2. I don't really care, as long as in the end this all matches and makes sense. Notice up here, this does say tool 1, and over here it already says tool 01. So you will have to make some slight modifications to things as you go forward. You'll also notice that in that same block or line of code, we're telling it to do a tool change, and that's good because we're saying, hey, here is this function we want you to know, this preparatory code. You're going to be looking for a tool offset, and you're going to look in the library for it. This is the tool that we want you to change to, so tool change, tool 1, and this is what it should be. This is just our comment section. Third block says turn the spindle on and do it in a clockwise fashion, so an MO3 as opposed to an MO4. Turn it on at a speed of 3000. Notice how each of these are all falling under their own column. We've simply highlighted X and Y here for you so that you see this is the first place you should be putting in X or Y values. And we're going to tell it to go ahead and do a rapid traverse. That is a G0 or G00. I just need to tell it where to go. I can't put this value in for you before you start because I don't know where you're going to start your plunge. I don't know where you're going to go first. You know that based on what you created, this document, and your table of all of the different coordinates. Keep this in mind. Whether you're doing absolute or relative, you're starting with a G90 because you need to go over to this point absolute from the origin, 0, 0, 0, or in the case of just XY, 0, 0. Notice that we don't, in relative, change to a G91 until we get down here to line 6. Also notice that this is where we call out that 91.1. When we start the relative, we don't do any kind of arc or curve in the XY plane, so we don't need the 90.1 G code. Up here in the absolute, we're not going to switch out of absolute, so we go ahead and call out that G90.1. All right, with all that said, you can start going from here and plugging things in. The next thing that you ought to do is rapid to a safe distance above. This is our safe position above the material. And then the next line is you plunging. So linear interpolation, plunge the Z down into the material so that it's at an absolute position in Z of negative 0.625 or 1/16 of an inch. Notice that we're doing it at F9. You could run this up to F10 if you want to go through and change those things, but notice that I did call it out for you up here as a 9 inch per minute. And that's what this comment says. What do you do next? And that's where you start filling in this table. You'll notice that with this table, I do provide you with a ton of space. So if you need to add more to this, by all means, please do. I certainly did myself. I had to add, I think, upwards of another 5 or 6 lines when I made my own code. You should be able to insert a row above or below as necessary, and then fill in the values that you need on your own. All right. You would repeat this process over again with the relative, but using the relative values. Whatever it is, whenever you are done with these, make sure that 1, it's shared with me, and 2, you've renamed the file so that it makes sense, right? So you'd want to put in something here that identifies that it is yours. Make sure that it is also saved in the correct place. I would recommend that this be in your CDF under a 2.3.3 folder, preferably shared with me. Then comes the tricky part. The part that it kind of depends on what you have at your disposal. All right. To get it into PathPilot HUB, we need a .txt file. That's a text file. Many of you probably know what a text file is. If I simply come down to my Windows button and I say do a search for Notepad, that pops up. Notepad or Notepad++. It's a really good option. I'll go with Notepad++. And you can see here are my absolute initials and my relative initials as well, as a second tab at the top, as I have done this countless times. When I go to put this information in here, it is probably best done by taking whatever I have on this sheet, copying it, and I'm just going to take this first little part here. Now let me take the absolute values. Control-C, copy. And then to get it into wherever, there's no link for this, to get it into wherever I need it to be, I need to have something open. Notepad++ is one of the things that we do recommend to you to use. Notepad is another one. You can also do this in a Google Doc or CodeWriter, and I'll show you those as well. So Notepad++, let me just go ahead and do a new file here. So new, and if I right click and say paste, this happens. And this looks cumbersome and kind of annoying. I'm down to like line 232 with code in 11 shown. All right, here's the deal. It only takes a moment to fix. If you simply delete that one, hit end on your keyboard and delete that, you just have to literally, like I say in the document, clean it up. All right. Some people have found a way to simply tell it to delete any unused space, and that's fine. If you can figure out how to do that, go for it. All right. Otherwise, you're going to have to come in here and clean this up so that it does stand out. You can hit tab to move things over quicker if you'd like to, and you'll find that it does take a minute, but it's doable. Okay. It took me just a few minutes to get this all cleaned up and placed in here. That's why, oops, this is very useful. Okay. Coming into looking at what we suggest to you, utilizing a resource like this, and going from there. Doing what you feel is best for you, and then documenting that is what I'm looking for. All right, if you choose that for some reason you don't want to use any of our resources, just be sure that you document the heck out of that, because I'm really going to question why. Let's say you wanted to use a Google Doc. You could do the same thing. File, oops, file, new, document. I have all of this stuff. It's in a table format. If I come over here and I right click and I say maybe even paste without formatting, I still get a bunch of empty space that I have to wind up getting rid of. This is why writing a very large code is probably not your best friend. I would not advise it. I try to stick with 40 or less lines because it is going to take you a minute. But once you do have this cleaned up a bit, you can then turn this into something that is considered a .txt file, download, plain text, .txt. Okay, so you will have to come in here and right click and paste it if you choose to use a Google Doc, and then file, download, .txt. If your computer doesn't know what to do with a .txt, it will still, at least through Chrome, through Google Docs, allow you to download it as that. Let me know if you have issues with it. Then over in the Code Writer app is the other place that you could do this. Now for me specifically, I have it as something that I can pull up pretty quick. You might want to do a search for it, but it is something that comes pretty standard, so it could be on a Chromebook if you're using that. And then again in here, if I were to paste what I had from before, it's still with all of those blank spaces. All right, this brings us to the final resource we need to get into. PathPilot HUB hyperlink jumps us to the login or create a login. You need to create an account. I already have one, and I'll be using that when I demo this for you. But here's where you'll put in your first name, your last name, your email address, create yourself a password, and match it. Tell it that you're using PathPilot for school. Tell it that you are an student in education from age 13 on. Pick your time zone that you'd like, and then decide if you want them to send you emails. You'd hit submit, and it should walk you through whatever process you need to do to create the account. It is free. It is something that you will have to do to be able to use this. I'm going to go ahead and log in with mine to show you how this works. Once you have an account and you can get logged in, you have to do a few things. It seems so simple that it is almost difficult at times to do. Now down here I have a former student's gcode.txt file in here. I could clear this out, but it is literally loaded into a virtual machine for me. So it's sitting there waiting for me to access on the virtual PathPilot hub. I can upload other files if I want to by browsing for them and then finding them wherever they are. This is the .txt file that you have created. You'll want to load in two different files, one for absolute and one for relative. You have some space. You see I've got one file in here and I've barely used any. Once you have the file loaded in or uploaded, you can click on Create Virtual PathPilot Controller. I have had this stall out on me occasionally. Just retry. I've had to retry 2 or 3 times in a row before when my internet is bad. I enter the PathPilot here. The controller that I have launched will last for 6 hours. So if you're going to be working on this for more than 6 hours at one time, just know that it will kick you out. So save your work. I'm going to enter the PathPilot. It does take a minute, so bear with it. You have to click on Connect. It is literally connecting to a virtual machine. Every time you open it up, you have to say that you agree to their terms and then come down and find your machine. Problem is, your machine isn't listed here. You need to click on Previous Machine Models. We are using the 770, the PCNC 770. And like I said, it does take a minute to load. Okay. Once it's loaded, there are a few things that you should probably do just to get used to it. If you hover over stuff, it does show you or tell you what they do. This is the main page. This is File, Setting, Offsets, Conversational, where you literally write the code on the computer that's at the machine itself. And this screen that you're seeing is just like the screen that you would see. It's a touch screen at school, but there is also a keyboard and a mouse and a jog shuttle. Something that I can move the tool around with or the machine around with using a specialized mouse, basically. The offsets are not anything you need to be concerned with at the moment. The settings, the file, those are some things that you might need to be concerned with, mostly file. If you ever get a status button, this will light up yellow and it'll tell you that you have an error. Okay, so for example, I'm going to come in and reset my machine. In real life, I would go through the process of referencing my Z, then my X and my Y. This is the process we would go through at the school. Right now, I'm not necessarily at a 0 position or anything of that nature. This is the window of what you're seeing get cut. I can right click on this window and go to an ISO view. I'm currently in a top view. I can also use my wheel to scroll in and out, and I can click on my wheel like it's a mouse button and pan around, or left click my mouse button to move or orbit around. Okay, so I'll zoom out just a little bit and pan over. To get the file that I want to cut, to have as a functioning file in here, I'm going to go to File. There are 3 screens or 3 windows to look at. This is what's on the machine itself. This is, in real world, this is a USB drive that you've plugged in, so a flash drive. And in this case, you'll see that this is coming out of my account. This is that file that I told it to upload before I started the virtual machine. But it's not on the virtual machine yet. I have to click on it and then tell it, copy this over to what I want to use on this PathPilot hub. So I press copy with the arrow that points this way. It's now over here. And if I click on this, I can either come in and edit that G code within PathPilot Hub's G code editor. And again, this looks very similar to what I would have seen if I were standing in front of my machine. In fact, I can even come in and tell this thing, instead of looking at it as plain text or a .txt, to look at this as having as the fact that it is G code, and it does do some color coordinating for me to help things stand out. I like to view it this way. This is up to you though. Okay. Immediately I start to notice that Gabe's file has some issue, right? There is a blank line at the top. The highlighting of the MO3 and MO5 and MO2 are fine. But I do see some other things that in a quick glance, and also I know what it's going to do, that there are some issues with it. Now let's for a moment pretend that I didn't pick up on any of those things, and I just double click on Gabe's file. It loads it into the machine for me, and it puts it over here on the left. Now this MDI is where I could type some things in if I wanted to. If I look at this now as an ISO view, it says, hey, you have already identified that there's this 0 location and this file is ready to go. That's cool. It's all fine as far as I'm concerned. But if I look very carefully at what he has going on with this file, I see that there's got to be an issue. All I see right now is a G. I come on over to, let's say, start this file, and it says, hey, you want to insert T1 end mill in this spindle and then press cycle start. Yeah, okay, I inserted T1. It's literally running through and looking to see that I need to put this one in. Cool, it's in, and oh no, I have an error. Okay, notice down here in the bottom right hand corner, it got rid of T0 and it added in T1. T0 is an empty collet. T1 is that first T. And it's just going nuts. It's going crazy. This is what's important. It is telling me where I have errors, where I have problems. You just have to look for it very carefully. On line 20, there is something going on. Some bad number format, okay? Truncated to 2 characters. It's even telling me what it is that's wrong. 0.1.1875. There's an issue there, okay? And then it says down here on line 20 that I have that same error, so it's identified it twice for me. It's really upset about this thing. So it's trying to run through it and then going, oh, did I make a mistake? Let me run through it again. Oh, nope, I found that same one. Yep, there's something wrong with this. Notice that also it says line 20, but my number is 19. If you remember, in that file, when I looked at it under the Edit G code, there was a blank space here. If I got rid of that, now they all match up. So instead of it being line 20, it really is line 19 in my code. Gabe just happened to have a big blank space at the beginning. So I'll come down here and I'll find line 19, and lo and behold, there is an X value that shows 0.1.1875. Let me get rid of something here. Let's say that I get rid of the 0.1 because I think that might be my mistake. It's not, but let's pretend that it is. And I say save. And then I'll close this. I have to say save. And I'll close this window. The file on the disk has changed. Do you want to reload it? Yeah, absolutely I do. So I'll say okay, and look, I get the little spinny wheel and it's reloaded, and oh my God. Well, okay. Gabe's initials almost work. It should say GAP, but something has happened. Notice that his G looks fine. It really does look totally okay. But the A, obviously, does not. So something happened when it finished with the G. I can click on each of these little line segments and it'll show me the code on the left where I am. Let's see. Looks like he starts here, does his plunge, linear interpolation here, to a curve, to a linear, to another curve, to a linear, to another curve, so forth, so on. He gets all the way back over to here. And then he says rapid upward. Go up. All right, cool. He does that. He goes up. And then he says go over with a rapid. Yep, he does that. That's line 19, and that was the one that seemed to have that error. Notice that that told me to go over to 0.1875. But remember, the error that I saw was 0.1.1875. This is where going back and looking at your coordinate system or your coordinate table is great. This is where going back and looking at your actual drawing or your Onshape file is a good idea. In this case, the error wasn't that it said 0.1.1875. The error was simply that 0.1 at the beginning. It needed to just be a 1. So let me throw this in. So I'll say save and close and reload. And there's still going to be another error, but let's take a look at it. All right, the G looks good, the A looks good, but there's something going on with the P. Get in closer on this for you so you can see it. So he plunges, linear, linear to the right, and then he does this arc on the very next line. Notice though that he has put a comment in that says it needs to be a counterclockwise interpolation. Well, it doesn't. If he goes counter, he goes to the left. He wants this P to go to the right. So he needs to come back to his code and look and see what his prep is. His preparatory G is a GO3. Doesn't need to be a GO3, needs to be a GO2. That's going to cause it to go clockwise instead of counter. So although he thought in all of his planning that that was the correct direction to go, it turned out in the simulation that it was not. So he goes down and finds where that curve happens. He looks for line 33, and even though the machine said, hey, we can do this, it still was an error. Didn't turn out the way his drawing or his Onshape file would look. I want this to be a GO2, and then I would obviously want to come in and update this to say that this is clockwise. All right, so he did a bunch of counterclockwise interpolations here, and then he did a clockwise one here. Then I would say save one more time. Now notice at this point I have gone in and made a few corrections, 3 or 4 of them. One just got rid of a blank line so that all my lines matched up with what Tormach said was the line number. And then one where I thought I'd made a correction, but in the end it actually wound up causing it to drive all the way through my wax block to make the A. But it did keep the machine running as opposed to coming up with some fault. The machine will identify that I had 2 decimal places, and it knows that that's not a good thing. So it's probably going to work now because I also then fixed not only that, but the P, sending it in a clockwise instead of counterclockwise direction. So let me say reload this one and put it in here. And now it does spell his initials, G, A, and P, and I'm going to assume that the spacing is all correct on these things. It's been a while since Gabe has been in my classroom, and since I've seen this file actually get cut. Now, this is a good screenshot to take. This looks like it will work. It is also required that you have a screenshot of it from an ISO view. 1, to show me that you know how to get to the ISO view, and 2, so that we can see what it looks like with its plunges and so forth as well. You can also run this if you'd like to from here to see what it would do, and it does run through the entire code the way that we would think that it should. Again, keep in mind anytime he does a circular interpolation, it's probably a good idea for him to have slowed down, but this is a lot of arcs that he's doing, and so he had permission from me, since they were very small arcs and we were going through wax, to not worry about slowing down at that point. This is definitely something that you need to consider and think about whenever you're writing this up in your paper at the end. Okay, so he gets all the way through this. Now, one of the things that I'm not showing you is how we would do an error cut, because we're not physically in front of the machine. When we are, I would have you go through this entire file once you figured everything out and do it 2 inches above the wax, just to make sure that everything looks the way that you think that it should. Then we would lower our Z down to the point that we would cut into the material. And that's it. That's PathPilot. You know how to do screen captures. At this point, you can't really do anything else with the file. So it's not like you could take this file and put it back over here, which I could overwrite this, but then where do I go from there, right? Even back here on this site, I can't do anything other than just delete it. So you will have to go back and make changes to your physical or digital copies of the documents that are part of the resources. Well, this has been how to get through this assignment. I know this is another hour and 15-minute long video, but it's here for you if you need it as a reference for the various different parts. I do hope that this is helpful for you, and I hope that you understand this is all about you trying to learn how to use the G code and get yourselves a few more points on our way out the door. Hope you have a great day and a good weekend. Talk to you soon.